Hey Victor, are you having trouble connecting to that software thing?
I'm just now opening a new tab. I was rearranging stuff on my desktop.
Okay, yeah. For some reason, it's still giving me the error, but I want to see if you can be able to get it.
Yeah, we started. Okay, so far what we have done is the sketches, which is the very base, and then we went to the solids, how to create different solids from the sketches. Now let's say if you're working with complex design, which is pretty big. Let's say, for example, let's see if I have an example. Here you go. Let's say, for example, you're building something similar to Lego, for example. Okay, something like this. Okay, and when you're building with Lego, what do you have? You have different building blocks, right? With these building blocks, you can create anything. Nowadays, you have these specific blocks for, let's say, this what I have here as a to build a car. But if you have the general versions, you can build anything. It's own to your imagination. It's similar for it can be similar to for any case. You can build anything you like. And sometimes you can do motion analysis, sometimes you can do simulations, stress analysis. If you're working with fluids, so you want to see how streamlined your design is for aerodynamics and not, you can do a lot of things. So for complex designs, you don't want to have one solid body, rather you will want to have is several parts. An ideal work example will be building a car. They design different part of it and send it to different sections of a manufacturers, and they will build different parts. Like, for example, the door will be made by someone. Front one will be from to one manufacturer, the back one might be from another manufacturer, or from the same manufacturer, different sections. They know, do you need to have all the details for the dies and cast that we'll be talking about later also in this workshop for that. So today's topic is mostly on the assembly. If you have the parts ready, can we build those assemblies? Everything, most of the things you need is already in the tutorials, but still we're going to go through it again. Now, if you click on the Solidworks top left, the new button, you will see this one, right? So far we've been working on the parts where we're doing the sketches and the solids itself. But when we're working here, we might want to do the assemblies where it will provide you with the tools necessary for that. Now, if you're working with assemblies, there are two approaches. One is the top-down approach, another is the bottom-up approach. Okay, in one approach, what you have is you build the parts separately. Okay, you build everything separately. Let's say, for example, if we are trying to build this one in the problem one from today's practice, what we're going to do is build all these parts separately first. Once we have built all of this together, we're going to assemble it top down. Another one is bottom up, where is you start working from the assembly itself. Okay, you first build a base which is going to support the whole thing. Then once you have everything, you just build the second part on top of that. So that will be visible in a transparent layer, and you can still keep building on top of that. Which approach to take depends on you. You can decide if you want to go with the top down or the bottom up approach. No, there is no restriction. Sometimes there might be, let's say if you have a big project where you have several parts and a different number of teams are working on it, chances are they will build their part from the specifications that everyone has been shared with, and then they will be assembled. Then again, if you're working on something like, let's say, a pipeline company where they're building pipeline around manufacture, let's say, an oil gas refineries, where one group may be working on building the new tanks, another one is for working on the pipelines, another one is building on new sections of it, of the whole of the plant. In that case, everything will be bottom up. All of the parts that you'll be another teams will be creating, you will be able to see them, but you will not be able to edit them. And when you're working with the group work, usually they have a service called PDMS, which is the oldest one. They also have some module for Solidworks to work in a group where, let's say, if you're sharing a network, you can start working on them together. So before we move on to the example, do you guys have any questions?
No.
Okay, awesome. So let's start by building a few parts. Okay, I'll be a little rough and I'll be missing a few details on this just for the sake of time, and because the focus is mostly on the assembly itself. Okay, so let's start with this. We have a hexagonal one. So the first thing, we're going to create the parts. Okay, let me see if we have something easy on today's list. Yeah, okay, so this sounds like the easiest one. We can play around with this quite a bit. Okay, so let's say we start with this. So now the first one is pretty straightforward. Okay, it's taking a little time on the computer. Okay, as always, we're going to start with this front plane itself. We're going to create this slot with holes on it. So let's see. I'm just drawing it using it, and we know the distance between this is 30. I'm using the millimeter scale for creating this. So 30 millimeters. On both ends, we have this radius S 10. Okay, so if we adjust one, the another one will be automatically adjusted as 10. And then we have two holes here, which has a diameter of 10. So what we're going to do is create this. I'm going to use the center line to create the center line here and do a mirror entity. As I like creating mirrors, and one easy thing about this is if I adjust the radius or diameter of this one, the other one will be adjusted automatically. So less work for selecting different parameters. Okay, now the thickness, if you look into this one is called a drive link, and thickness is given as 5 millimeters. So I'm going into the feature, extrude, and the thickness I'm going to create for this one is going to be 5 millimeters. Okay, so we're going to save this. Let's save it as problem 3. I'm going to give it a name as the drive link. The part, first part. Okay, the second one is giving us the whole thing. So let's jump into the other pieces. So we'll be building the easiest parts first. Where now, if you look into this one, we have two pegs. One has a diameter of 10. Both have 10, but one is 10 millimeters in length, another is 15. Okay, so it's going to be pretty straightforward. We'll have the sketch, nothing much to do on this too. So we're going to just create it as it is. And we're extruding it to make it 10. Okay, click OK. I'm gonna save it as 10 by 10. Oh, peg. And let's create the other one also. Okay, and what we're going to do is we have that this is 10, but the extrude is going to be 15. Say this as 10, 15 peg. Okay. Next, we have this again, another slot, but now we also have a hole in between. And if you see, we have two of those. One has what's called the center link, another is called the rocker link. Okay, so let's start with the rocker link. Okay, so again, let's start with the front one. We're going to use the slot tool to create this. Okay, and I'm going to draw the center line here. And we're going to draw another slot because see, both of them have the same shape in terms of the slot. So now smart dimension, we know one of them has center to center is 100, another one is center to center is 70, right? So center to center here is 100. And center to center here is 70. Okay, the thickness here we see as 10 for the inner one. Okay, so for the inner one we have is 10. For the outer one, we need to adjust this radius, as you see, because this radius is going to be the distance from here to the center. So that means it's 10, and the thickness that's going to be 20. Okay, so we have a radius of 10. Good. Now, for the center one, we have this as a diameter of 10. So straightforward, we have the smart dimension tool, draw it as 10. And then this is that mirror entities to just mirror about the center. So now the thickness is given here. Again, this is 5 millimeters. So what we're going to do is make it 5 millimeter and save it. Okay. Now for this one, we will have is rocker link.
Hey, Syed.
Yes.
The thickness that you just did right now, how did you click all of that to where everything would be extruded? Was it just
okay. Let's go. So SolidWorks automatically picks up where the close contour is. Right now it figures out this is the maximum contour it has. So if you click this one, it's automatically picking that up. But if you think this is wrong, what you need to do is go into here, which is called the selected contours. Select this box, and let's say you're interested only in this one and this one. You just select those contours that you need, and you can invert the selection. Make sense?
Yeah, it does.
Okay, so let's move on. So we have this, okay, the first rocker link, that looks good. Now we have the center link here, right? Let's build this one. This is something similar. Okay, now one trick is you can draw it again. Another trick is in the assembly, you can save it as a new document while modifying most of the things. I'm just gonna draw it again either way so that I have separate files. Sometimes it's a good idea to have, if the names are different, or if you think the specifications might change later on, saving it as a different name, so that it's not gonna modify anything other than the ones you're working on. It might happen is that you're changing specification, and SolidWorks usually links everything in the assembly. You might be messing up something. It's better to be safe. So I'm gonna go into the slots again. Okay, and circles. Okay, I'm not gonna create the mirrors this time, just for diversity here. So we know here is 90. Then we have the center to center of this is 50. Now we have the thickness, but in this time we have the radius as 5. So this is going to be 5 in radius. And the outer one is 10. And the inner diameters are 10 each. I'm just going to make it 10 here. And for this one, I'm just going to select this one here. So it's going to pick it up from there and click OK. Now you're done. Again, what we need to do is click the extrude boss. Usually it picks up. Now for this one, the thickness is again 5 millimeters. So that's good for us. We have our 5 millimeter and we can go from there. Okay. And this is called our center link. So center link. Okay, now the last part, which is going to take a little while. Okay, so any ideas how we should build this one?
Would you do like maybe like a center arc, or would you do a straight like triangle and then you can curve off the edges and you add like a center arc at the top of each point?
Yes, we can do that. And the other one that we were trying to say is creating a center link, maybe say somewhere around here, and create one side, we can mirror the other side. Both works. Okay, now the only change will be around somewhere around here, where you need to do a little modification, but still it's gonna work as a one. So as you said, let's do it the other way, right? Where what you were suggesting, maybe let's start with a triangle itself, right? Okay, so I'm just drawing a triangle, but if you see, I'm drawing it based on a center line. You will know the reason why I'm doing it like this is because if you think carefully, what I'm trying to draw is the connection between these holes, I mean, the center lines we have here. So let me see if I can draw something here with the highlighter. Okay, so what I've drawn right now is this point, this line. So, oops, let's draw this line, not the outer ones on it at all. So we have the smart dimension tool to know that this distance has to be 80. And again, the same thing for this one is 80, right? As you can see from here. Now, once you have that, the next question is, what's the thickness of this whole thing? It's 12, right? So 6 in either side of the center line. So what we're going to do is go into the offset entities. Okay, select the lines that we're working on and then make it as 6 millimeters there. Okay, and you need to select this one, which is called bidirectional. So now it's going to create on the both sides of your sketch, and that's going to be the main sketch that you want to start working from. Okay, so far so good. Now we need to worry about these circles. So let's start with the circle, and the centers are going to be still this. So you know, that's the reason we started with the center line. So okay, so we had 2 of them, and here we have something called a 50, but that has to be an arc there. So we select this and create something. Okay, yeah, this thing likes to be trouble every now and then. Okay, and so now for this inner one, we know the radius is 15. For this one, we have, if you see here, this is 15. And the outer one is also the same.
Would you need to do a construction line so that you can be able to remove them, those corners, or no?
Oh yeah, we'll be removing them. You're talking about these portions here, right?
Yeah, so that we can cut out whatever we don't need.
Yeah, we can. Oh, and we'll be doing that for sure. Okay.
Yeah.
So now we have this radius of 15, which is basically diameter of 30. Okay, and these are pretty small. So we're gonna go into the trim radius. That's for what we need, and we're cutting off whatever we don't need. Right. And as you can see, we don't need a lot of the things here. So you have your first piece. Now let's go to the second one. Let's zoom in to make sure we're cutting the right things.
I don't know why I thought that in order to do what you're doing right now, you needed to do actual construction lines, but I guess
Yeah, you can do it. You can do it. So that's the classic way of doing it. So this is what the Solidworks is an advantage on. So previously, you might have to do some construction line to know where to trim. The trim closes, trim away inside in the corner. But if you, they have this power trim, which is the advantage of the Solidworks. If anything is intersecting and you can cut away. Let's say, for example, I know that this is one of the this is one of the points, and this is one of the points. So if I cut this, anything within those points will just be taken away. So
okay,
we're blessed with this advantage. Okay, so now we have this corner here, which is 10. So we're gonna take is this one, which is called the fillet, sketch fillet. Then the radius is already selected 10. You can just select this, click OK. Now, if you notice carefully, there is something written here. All fillets and rounds are 3, a radius of 3. That means if you notice carefully, you have something around. Let me delete the other ones first. There are some fillets around here, all right? And this will all be this 3. So we make it 3, and we're going to select these corners. This one, and are we missing anything here? I don't think so. Okay, this one and this one, and click OK. So now you have everything ready. Okay. What we're missing is these points here. So for the sake of, because let's see, for the moment, I think we don't need those because we're not using any of those for any work. Do you want me to draw those, or just we're gonna leave them just so that we can jump into the assembly itself?
I don't think we need to draw them. I think we're good.
Okay. Okay, so let's see. Let's finish up this. What we have is 10 here and 10 here. Okay. And for this, we know the thickness is gonna be 10 millimeters. Okay, so feature, extrude. So what we're gonna do is 10 millimeters, click OK, and this is called the plate. So let's save it as the plate. Okay, now we have everything ready. We can just go into the assembly. So we're opening up the new file and going into this option called assembly. As all the other files are open already, you will see when you open up the assembly, everything is shown on the left. In case it doesn't show up, you can always select this option called browse. And if you do so, you can just select the files you have there. When you're working with the assembly, one thing to remember is you need a fixed base. Okay, here we had what? 1, 2, 3, 4, 5, and 6 different parts. So you need to make sure that one of them is your base, and which is fixed. It doesn't move no matter what you do. And the other ones can be movable. It's completely fine. That way the assembly components are pretty sturdy, and even if you're doing some motion analysis or something else, you can play around with it pretty easily. Okay, so what I'm planning in doing is I'm gonna make this big piece as the fixed one, and other ones will be the float one. And I will show you if you want how to change those also. So what I'm gonna do on the left side, I'll be selecting everything here first by pressing a control button on my keyboard, and now I'm gonna paste everything. So just click, 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 click. I'm just scrolling out for space and click and click. So everything now is on my workspace here. And as you can see on the property manager on the left side here, it says F, and for the other ones, it's a dash, right? So whatever it says F is the fixed one. As you can see, this small cylinder is the fixed one. But what we plan on doing is making this as the fixed one, right? So what you're going to do is right click on it and select, make it, you will see this option called float. So now everything is float. So we're going to select this. So we know, okay, this is the plate. Right click on it and make it fix. Now it's not gonna move, while others will start moving. Okay, good. Now we have everything, all the parts ready and in the same space. What we're looking into is this option called mate. If you click on it, the left property manager will show up, and it has a number of options for your assembly. Usually you will see the most important ones here. A few of them can be found on the advanced mechanical mates on the other ones. Most likely, if you're using for motion analysis and other things, you're gonna use this two mostly, and sometimes the width and symmetry ones. For the mechanical ones, if you have created something like the cam, slot, and hinge, so to create those motions, you might be using mechanical mates. But the same effects can be created using the standard and advanced mates too. Okay, so let's start with the basics. So whenever you're selecting something, it will automatically create a coincident mate. If you're planning on changing it to something, it might change. So I'm going to show you one at a time. So let's say, for example, here, if you look into the assembly carefully, the plate is connected with the drive link itself, right? So, and this, I think this is the drive link. Yeah. So for the drive link, they are connected in one surface. So maybe I'm thinking of, hey, this surface will go on top of this surface. If you click on it, it's been selected. You saw that it's been moved, and click OK. So now what happened was you have defined a relation between them. Is that the surface, the other side of this drive link surface and this surface will always be coincident. That means it will remain in the same plane. It doesn't have to be in a fixed position, but even if you're moving it along that, you will always see that it is on the same plane here. Okay. Even if I'm saying that I'm moving it to the right, you will see it has moved to a distant, but not on the place you want. Okay, so make sure when you're defining these constraints, you know how you do it. The next one is, let's say, the concentric one, which is this. So if you're selecting concentric or cylindrical surfaces, and you will see that they will align. Now on this case, as we have they both have the same center axis, they will be moving along the center axis, but you are not defining it to where or where not it can move. In this case, it has to be moving within this surface and within this axis itself, right? So if I add a second constraint here and here and click OK, now what we have done is we have restricted its movement just within the perimeter of this, and it's not going to go anywhere. It's going to move just circularly around that point itself. Sounds cool, right? So now what we're going to do is look into the other one. There is another option which is called this tangent here, right? Tangent is basically, it's if you're selecting the concentric surface and a straight surface, it's going to create a tangent surface. Now, if you're planning on moving it along, you will see no matter how you're moving, it's going to always have the same surface connected. It's the same as the coincident one. Anyways, we're not going to need this here. One important point is sometimes you might have to reuse a few of the pieces quite a few times. If you notice carefully, this 10 by 10 peg is used once, and this 10 by 15 peg has been used 3 times, 1, 2, and 3 times. So this is the 10 by 10 by 15 one, and you need to create, have a copy of this twice. You can do same thing, go into the insert component and reinsert this parts as many times as you like. Or what you can do is just exit the mat, select this object here, control button on your keyboard, and just click and move your cursor. You'll be create another version of it. And if you look carefully here, it's just creating another instance of it on the property manager. It's not like it's just making anything else or creating a new file on your root directory itself. So once you've done this, let me save this before anything happens to it. Assembly complete. Okay, so we know this 10 by 10 peg is gonna go here. So the 10 by 10 is this one, if I remember correctly. And I'm gonna select this mate. Make that the first thing first, we're gonna make it concentric. The next one is we're gonna select this upper surfaces. So now it's all the way in, and we know it's gonna be inside of that link. Okay, awesome. The next part is the center link with the drive link. So let's see which is the center link. This is the center link. So I'll be selecting this concentric version of it and this concentric version of it. We have something here, and now let's select the surfaces. Click OK. Same thing we're gonna do with the other one. We already know this is the one that's left. We're going to select this. Now I'm going to bring a few things that's going to be fun. First thing first, when I'm selecting this, let's not select this at all. Let's do a little trick here. Because I haven't talked about this. Yeah, I haven't talked about this. So now I'm selecting this surface here and this surface here. This is concentric and this looks fine completely. It's just getting assigned. But what if we started with selecting the surfaces themselves? So if I'm selecting this surface and I want to make it concentric with this one, chances are it's gonna go overlap with one another, right? Because it has to be on the other side maybe. So instead of just going with the hassle of selecting the other surfaces by deselecting it, what you can do is something called the mate align, which you can see here. If you click on it, it will flip the object for you and make it the surfaces coincide from the other side. So it's just gonna flip the object itself, and you will have the option to select which portion you want to connect to one another. Okay, easy peasy on that one. Now we're gonna go with the same thing again, making them concentric. The rest of the piece is quite straightforward from that point on. So we're gonna select this and this, making them concentric again. Okay, yeah, I think I made the assembly wrong. That's supposed to be under. Let's see. So now let's say if you made wrong by any chance, right? What you're gonna do is go to the main sketch itself and see which are the links that you have created and which are wrong, and then you can delete them. So you can just select this here from the tree itself, right click on it and delete. Okay, so now we have deleted both of them. There is no constraints. Let's go to the mate and make it the correct mate. We want this bottom surface with this surface here, and we want them concentric. Okay, and then we will have this one and this one concentric again, and it should be touching the surfaces from this side. Okay, so now you have everything ready and you can make it move any way you like if you want. Okay, now of course it's not on the same arrangement. You guys can make those changes later on. I'm just gonna add these things first and we're gonna talk about a few other things. Okay, so now let's exit this mate and I'm going to delete these extra ones. I'm not going to add this because we're not going to need them for discussion for the moment, but please add them later on when you're practicing. So now if you look carefully, we can make it move, right? And this one is making a whole 360-degree angle here, while we have some angles around here. And what you can do is restrict them. That's the fun part of it. Or make some of these things parallel to one another, or some other cases. So if you go into the mate itself, you will have this option called these angles. So let's say if I'm selecting this surface here and here, okay, they're trying to make it as a plane or as a coincident, but you can also select which angle do you want them to be and adjust them on those angles. Okay, as you see, I'm changing it, these angles are changing. Or maybe you're someone who says that, hey, I don't like that one. What I want to do is go into the advanced mate and define a variable angle. Okay, so let's say you decided that, hey, the minimum they can bend is, let's say, 30 degrees, and the maximum they can bend is, let's say, 115. Click OK. So they will be restricted in terms of the movement, if as long as I mean, what the angle limit you have added to this. Okay, so maybe if you plan to go beyond that one, you need to go and edit this mate itself, which is basically this limit angle. Go back there, right click on it, go into the edit features, and then just add this a change or make this dimensional between the angles change as you like. Okay. A few things I didn't talk about is this one, which is the variable distance. Let me do a quick thing here. Let's bring make another copy of this. Okay, it's hang. Okay, yeah, it looks okay. So let's say I'm gonna getting another copy of this. Okay, now for this one, you decided, I'm just making this up, this is not part of the problem, that maybe we will have a concentric part with respect to this, and maybe we will be selecting these two surfaces. Now it's gonna align that there, but you want to switch it, so I'm not selecting this mid alignment, so it's on the outer side. You decided that, hey, whatever this object is, we want to make it a little distant from the original object itself. So we can just make it like 10 millimeters. So it's going to be always be 10 millimeters only. Or if you go into the advanced mates itself and select this one, so you have 10 millimeters and you can decide, hey, as close as maybe, let's say 5 millimeters it can go of the object, and maybe as far as 50 millimeters. If you click OK to that, you will be able to see that it is moving along that axis itself. And that's it. You have all the assembly tools you need to create any assemblies, and you can just come up with any number of assembly combinations for this, and you should be fine with this. One more thing that I actually want to show today, it's called the configuration, and not configuration, of how you want to display these things to anyone. So if someone just looks into this but you want to show them different components of it, it's a part of a presentation. So on the left property manager, you will see this, which looks like a tree-like structure. If you go there, you will see this. This shows all the parts of the assembly. Right click on it, you will see these options here. One of them is new exploded view. Select that. So now you will have the option to disassemble this whole thing. Let's say I'm selecting this one first. You will see this X, Y, and Z. You can just pull them out. And that's it. Just click OK. Now I'm just showing it as one of them, or maybe you can just do this. Okay, let's do this. Well, add feature. Okay. If you want to do it for multiple of them, you can do the same thing. Maybe for a different object, whichever you want to move, just select them at one go, click OK. Now you will have some exploded view created. I'm just showing only 2 or 3 of them here. This one will contain everything you need. Right click on it. If you click collapse, it will go to the original position. But if you want to show someone that a few pieces that's going to come out of this, right click on it and click explode. And it will show you an exploded view with different parts of it. If you like, you can also create this, call this animate collapse, and it will show you in an animated view how every piece goes to where. So if you have something cool that you're creating in an assembly and you want to show people that, hey, how they disassemble, which is basically, if you right, let's see, let me close this, right click on it, create animate explode. It will show you by removing all the parts separately. And if you want to do the other way around, just cross this, right click on it, and just create animate collapse. You can also save this later on. So, just make a video out of it and show your friends. So that's all I had for the assembly today. On the Blackboard, what I did was for you guys, created a few samples so that you can play around for the assembly. I haven't created this, given you these parts. The problem number 2 is pretty complex, as you can see. It will be a good practice for creating solids and the sketches, but I've also provided you with the files of all this. So if you just want to practice the assembly, just look into this one, get a direction. The other one has all the parts needed. You can just create it right away, just creating the assembly. This one we have showed right now. This is also straightforward, easy. Just play around with them, see how the assemblies can be worked out. And I've also added a few extra ones, like on Blackboard is this one. Let me load it. Okay, so this Lego pieces, you will find on that file only the ones on the wheels, this base, and this red base, and the yellow base. And now you can just create multiple of them and try to see if you can figure out how this assembly is being born. If you look carefully, the wheels are moving. So you need to figure out in which manner you need to select the mates so that it can still rotate within its base. Okay, this is one of them. Another one, let me see if I can pull that one up also. Okay, it's our Lego man. So I provided you with 2 Lego pieces, so you can just play around with them and see how they works. Okay, and if you like, you can move their legs, hands, anything. Okay, any questions so far?
I had just one question. So did you create the parts in the assembly or in the parts section of SolidWorks?
Which one? For
Just
this?
The actual parts themselves. No, so like when we were creating like the pegs and the base, was that being created in the assembly section of SolidWorks or the part?
No. They were being created on the separate file sections of it. Okay, so let me see if I can pull that out for you. Where is it? Tutorial problem. Okay, so if you notice carefully here, I have this folder problem 3, and I've created all the parts separately and saved them. This is the important part. You need to save them first. Okay, as the other files were already open in it. That's why it was showing up on the left side. If it was not, so let me close everything for you. Okay, my computer, it's a little slow. I have a, yeah,
Hey, Sam,
Max.
I'm gonna go ahead and take off.
Okay, yeah, sure.
All right. See y'all later.
See you. Okay, so I'm gonna close everything. I'm assuming we have nothing there. Oh, my bad. Now, if you create this, all the parts that we had, we were created on the part. But when we're doing the assembly, we need to create a file on the assembly file. Okay. At the beginning, you will have nothing. Something like this. You just go here on the left side property manager, go to browse, and whichever files you need for that, just open up. That's it. And then put them on your screen, click, and click. That's it. So everything you need is here. I think I hope I answered your question.
Yeah, you did. Thank you.
Okay, so that's all I had for today. And basically, these are the components you're going to need for creating your assembly. If you want, like I said, go into the practice files, create the parts from scratch, and then assemble them. And like I said, I've already put 3 files, which is problem number 2, that Lego man and the Lego car pieces also on the same file. So you can just try assembling them if you don't want to draw anything again. Either is fine as long as it works for you. And on Thursday, we'll be meeting again to see if you guys have tried this, if you have any problems, and we will solve the problems from that point on. If needed, we can just go through another problem. Sounds good?
Sounds good.
Okay, so that's all. I'll be here for 9 more minutes till 8. If you want to try something on the meantime, or if you have any question, I'll be here to answer them.
Alrighty. I'm gonna go. Well, I'll try to see if I can fit in some of the practice problems either tomorrow or early on Thursday. But I know definitely I'm just gonna be doing a lot of SolidWorks over spring break as well.
Okay, it's complete. Can you tell me